So, hi everyone, I welcome you once again to Dynamic Coaching Center. So, this is yet another session, but in this session, we'll be discussing about a few of the past question papers from GATE for the same topic, radiation mode of heat transfer. So, here is a question which was asked for once in mechanical as well as production for GATE 2012. So, for an opaque surface, the absorptivity alpha, transmissivity tau, and reflectivity rho are related by the equation. It's very simple, right? We generally know that when two bodies are in radiative mode of interaction, so when two bodies separated without any medium, we know that these two bodies will be now interacting with themselves by radiation mode of heat transfer, and we know that the sum of absorptivity plus reflectivity plus transmissivity term is actually equal to 1. But the question here is being asked for an opaque surface, right? So that is a one, and for which how far the equation will be reduced to. So option A is absorptivity plus reflectivity is equal to transmissivity. Option B, it is reflectivity plus absorptivity plus transmissivity equal to 0. And option C, it is absorptivity plus reflectivity equal to 1. And option D, it is absorptivity plus reflectivity is equal to 0, right? So we'll just get into the solution. It's very easy. We know that for an opaque surface, there is no chance for transmissivity. So I can say that the term tau will be equal to 0. So we know that in general alpha plus rho plus tau should be equal to 1. Since for an opaque surface there is no chance for transmissivity, so the sum of other two terms should be equal to 1, which is absorptivity plus reflectivity. So this is what the answer what we are actually arriving at. And if you just get back to the solution, you can say that the option C is the correct answer. Hope you might have understood this. We'll just move on to the next question. So here is the next question. Consider the radiation type of heat exchange inside an annulus between the two very long concentric cylinders. So there are two cylinders which are concentric with each other, and in general when you have been given with these kind of questions, you can assume that both the cylinders are of same length, right? And the radius of the outer cylinder is simply designated as R suffix O, and that of the inner cylinder is designated as R suffix I. The radiation view factor or shape factor or geometry factor of the outer cylinder onto itself. So question was asked in the year GATE 2016, set 2 for afternoon batch, right? And these are all the four options which has been given to us. Option A, it is 1 minus root of Ri by Ro. And option B, it is root of 1 minus Ri by Ro. And option C, it is 1 minus Ri by Ro whole power 1 by 3. And option D, it is 1 minus Ri by Ro. So these are all the four options which are left to us. And let's first try to convert the given statement into a diagrammatic format, as I usually used to say. So we'll consider two concentric cylinders. Both are of same length, we can assume, as I said. Right? Now, between these two annulus gap, we assume that there is no medium present, so that radiative mode of heat transfer is the only thing which is possible. And let's take the inner cylinder to be 1 and outer cylinder to be 2. Now they are asking you to find out the view factor of the outer cylinder onto itself, which means F22 is what been asked in the question, right? So this is what you have to find. So you should actually stick on to the previous videos where I have discussed about the concepts related to shape factor and everything. So those who are actually new to this particular channel, you can just refer to the previous videos which I have made, and for your reference let me just give you the required links in the description section and you can access that. Try to watch those videos first and then try to come back over here so that you will be able to understand this question in a better way. So now whenever you have this kind of shape factor or view factor problem, you should be always thorough with your summation rule, which I have said. And then you should also know about the superposition principle and also the main thing, which is reciprocal theorem. So once if you are thorough with these kind of concepts, then it will be very easy to handle these kind of questions. It's a matter of fact. So we'll just get into the solution, how to solve this particular problem. Now, so as I said that it is also given that the inner cylinder radius is Ri and outer cylinder radius is Ro, right? Now since the first cylinder is actually concave, so the fraction of heat leaving from the first surface and falling on the same surface is actually equal to 0. So already we have seen some of the basics that if your surface is flat and if you consider this surface as 1, then there is no chance for the fraction of heat leaving from the first surface and falling on the same surface. So we can say that it is 0. The same thing is applicable for concave also. So concave in the sense it is like this. If it is convex, then there is possibility for the fraction of heat to fall on the same surface, right? So F11 is going to be 0. Now let us apply the summation rule as I say. So summation rule has to be applied for one surface. So if I try to apply the summation rule for the first surface, so the fraction of heat leaving from the first surface can either fall on the same surface or it can fall on the another surface, and its sum of the probabilities is equal to 1. But we already found that since it is concave, this value is 0. So I can say that all the heat leaving from the first surface has to fall on the second surface and its answer is 1, right? But we need to find out F22, right? Now let's move on to the second surface and try to apply the summation rule. So I can say that the fraction of heat leaving from the second surface can either fall on the same surface since it is convex, or it might even fall on the first surface, and sum of these probabilities should be equal to 1. Now in order to connect the first surface with that of the second surface, always we used to apply the reciprocal theorem, which states that your A1 F12, and you can also look for the subscript here, and it is actually 1 and corresponding area should be equal to A2, so it should be F21, right? Now already you know that your F12 answer is 1, right? So if you want to find out F21, it should be simply equal to A1 by A2, right? So area of the first surface, so you can consider the lateral surface area, which is, you can even go for pi dl, but they clearly mentioned in the question about the radius, not about the diameter. So you can even go for 2 pi rl instead of pi dl. You can go for 2 pi rl, and since it is for the first surface, you can go for 2 pi ri into l. And similarly for the second surface area, you can go for 2 pi times rho into l. So you can cancel the 2 pi terms both in the numerator and denominator, and also the length, assuming that both the cylinders are of same length as I said. So it will be simply Ri by Ro, right? So now you have found out your F21, which can be substituted over here, and now you can rearrange to get this F22. So your F22 will be simply equal to 1 minus F21, and that is equal to 1 minus Ri by Ro, right? So I can say that if you just get back to the options, option D is a correct answer. So seems to be a simple one once if you understand the concepts, and several similar type of questions have been asked so many times in most of your competitive exams like GATE, ESE, and even in the combined engineering services of your TNPSC and everything, right? So we'll just do one more problem for this particular session, and here is the next one. The emissive power of a black body is designated as P if the absolute temperature is doubled, the emissive power becomes. Question was asked in the year GATE 2017, again in the afternoon session, and it is clearly a 1 mark question. Option A 2p, option B 4p, option C 8p, and option D 16 times p. See, whenever there is a statement like this, you need to actually go for the comparison of the two statements, right? Now we know that emissive power is usually designated as E, and here in this question they have asked you to keep it as P, and that has been actually given by emissivity times sigma T power 4. But since they have clearly said that it is a black body, your emissivity is equal to 1, right? Okay. Now let's take the temperature to be T power 4, or you can even take T1, right? Okay. Let it be E1, or now you know that this P has been given as sigma T1 per 4. Now, what happens suppose if the temperature is doubled? Now, let us take the next temperature T2, which is 2 times of your previous temperature, right? So, this has to be substituted here. So, which means generally you might have written your emissive power for the second case as emissivity sigma times T2 power 4, but again since it is black body you will go for the substitution of 1, and instead of T2 you can now substitute 2 times of your T1, so it is sigma into 2 times of your T1 power 4, right? So 2 power 4 is what you are looking, and it will be 16, right? So it is 16 sigma T1 power 4, right? And you know that sigma into T1 power 4 is already been kept as P, right? So I can say that the new answer would be 16 times of your old answer, right? So this is how you try to solve this problem, and hope you can understand that your option D would be the correct answer. So let's get into the solution. So option D is a correct answer. We know that you can even go for this. Let's say the emissive power is actually been asked to kept as P, and we know that it is directly proportional to 4th power of Kelvin temperature, and the emissivity term is been neglected since it is black body radiation, right? And for the second case E2, you can say that the temperature has been doubled, right? So if you try to go for E1 by E2, it would be T1 power 4 by T2 power 4, and instead of your T2 you can even go for 2 times of T1 power 4. So T1 power 4 can be cancelled in both numerator and denominator, and 2 power 4 will give you 16, and if you rearrange the terms you will be able to get E2 is equal to 16 times E1, but you are supposed to keep your E1 as P, so I can say that the emissive power for the second case would be 16 times that of your first case. So option D is a correct answer, which we have sorted out. Hope you might have enjoyed this, and if you like this video, please do subscribe, review, rate, and recommend to your friends. And if you have any doubts, you can just put in the comment section. Let me try to gather all your doubts together and try to explain that in the next video. And try to work out these problems then and there, because we are mainly concentrating for most of the competitive exams. And for any special videos or private videos, you can just contact us through the mail IDs which has been given in the description, or else you can also call us with the phone numbers which has been mentioned in the description link. So try to watch the videos regularly in a orderly manner, so that you'll be able to understand in a better way. We'll just meet up in the next class. Thank you.